we discussed what VMware is, or what virtualization is. So we had a hardware. On top of it, we have an operating system, which is our hypervisor. And that hypervisor manages our VM. What's our VM, virtual machine? Again, we have some hardware, which is a logical hardware. Then we have our OS and kernel. And then we have our apps. When we are talking about Dockers, we have our hardware. We have our OS. So if we install with, if we go with the installation of CentOS, Ubuntu, any operating system, while we are working with virtualization, actually we have the complete OS, the complete kernel, all the allied packages. And even if we go with the minimal install, the size cannot be less than 400 megabyte. And it can go up to 1 GB, 2 GB. And on top of that, we install our apps, Apache, PHP, MySQL, and so on. And if our VM and we can have OS Windows, or we can have Unix. It doesn't matter. When we are working with containers, containers actually work in layers. So again, we have our OS, we have our hardware, we have our operating system, we have our libraries, and we have our further more libraries, and we have our app. This hardware will be shared from the main hardware, just like this. But if our app or our container is developed on a Microsoft platform, or if our app is developed on Unix platform, so it will only learn if the base OS is Unix. There are workarounds that you can run a Windows application on a Unix system, but there are workarounds natively. It is not that efficient. And one more thing is that in container, the container is deployed using layers. Operating system is one layer. So let's say if I am installing Nginx, so let's say version 1.22, then I am installing Nginx 1.24, and then I can go with Nginx whatever the latest is available. Let's assume we are installing 3 containers of Nginx, all with different versions. So they use the same operating system on the backend. They require the same libraries, and only the app is changed. So what Docker will do, the other deployment will not download the OS again. It will not download the libraries again. So it will just install or download the top layer, and the lower layers will be shared among all the containers. If we have more same containers, so these layers will be used from this container. And the size of container is mostly, the operating system is a very, very small footprint of operating system, which is mostly Alpine or Debian. And the operating system Alpine is just 5 megabyte. So in those 5 megabytes, we have very minimal operating system with very restricted, very little libraries, very small functionality of bash or shell available. And then on that OS, let's say I'm talking about Alpine, we want to go with Nginx. Nginx requires very particular libraries. So we install those libraries only, and then we can install Nginx. There will be no NTP running. There will be no, there are so many softwares, the network configurations. There are so many things that will not be installed natively, just very small footprint. And let's say that the size of the app will be now, here it was 400 MB, it will be, let's say 40 MB. So the footprint of a container is way smaller than a virtual machine. Plus, it shares the resources, like it shares the libraries or it shares the layers with other containers. So copying a container, or if we are cloning a virtual machine can be 400 MB, it can be 1 GB. Of course, copying 1 GB and copying 40 MB, there is a hell of a difference in deployment time. You can deploy containers very quickly. Any confusion in this? If you have no background noise, you can unmute your mics. So are we, Abid, are we getting the difference? That what's the difference between container and virtual machine?
Yes, since the virtual machines are like more in size, I guess that's why. That's the main
Yes.
difference I'm seeing here. Like
And we are
containers
not
are just
sharing,
space.
anything between virtual machines. The OS
Right,
are totally separate. The apps are totally separate, right?
right.
Okay. One more thing. If we are running virtual machine, so we are talking about virtual machine. The virtual machine will run in an isolated environment which has no way to communicate with this OS. It has its own OS running inside. We discussed many times. And let's say if we are running Nginx will run on port 80, and we will be using this physical OS network card, and our traffic will go out. In case of a container, we have total different scenario, because we have no virtual machine running, and we are talking about sharing a library. So what happens is, let's say we have our container Nginx 1, Nginx 2, and so on. And this is our operating system. So the main difference is we will use the networking of the main operating system. And this Nginx container is running on port 80. This Nginx is also running on port 80. So we will deploy any number of containers with the same port 80, and these will be all isolated containers, and they cannot talk to the main OS. And we have to define, okay, the OS is having IP 192.168.16.147. Now we have to make a mapping that if our website is running on port Nginx port 80 inside this container, so we have to create a mapping that if something hits on port 80, take it to the port 80 of a container Nginx. And for 8080, you can connect this to this Nginx container. If we do not define this, the containers, they run in isolated space, and any number of containers you can run, and all of them will run on the default, on their default configuration. Like if we are talking about Nginx Apache, they will be running on port 80. So we have to manually create this link for the networking. And we need to do the networking manually, and we are using the network capability of the main operating system. We don't have virtual switches here. We don't have distributed switches here. We are using the native OS networking and kernel for these containers. So I have actually already installed service docker status. Yes, I have already installed my Docker container. I will provide you the documentation how to install it. And my Docker is already running. This is my base operating system. This is my physical machine on which Docker is running. And let's say if I want to say Docker PS, with Docker PS command, we see if there are any running containers there. And with Docker PS -a, we can see if there are any stopped containers there. So from where we download the containers?
I mean, we can pull the containers or the images, right, from Docker Hub.
Yes, from the Docker Hub. I am going there, just going to share the screen.
And the major differentiation here is, I guess, from Docker and virtual machines, that Docker uses packages and libraries instead of using all the kernel or the operating systems of any application, right?
It uses actually it has its own operating system.
Yeah.
But that is very, very, very minimal operating system. And
yeah,
plus
and
those are considered layers. Operating system is one layer. On top of it, we have another layer, maybe some other dependent package for the Nginx. Let's say if we are talking about Nginx.
Right.
On top of it, we have another layer. So all these layers together, stacked together, everything packed together is a container. So why are we using term container? We are saying Docker. So these are the shipping terms. Like,
yeah, we can add the packages and libraries of multiple applications. So
application inside the same package, and that
the same thing.
Package is like packing everything inside a physical container.
Sort of ship.
On the ship, we have the big ship, that's a Docker, and we are putting containers on top of it, and every container packs everything which is required to run that application. So
yes, and
again
benefit for shipping, and as well as it's lightweight, right?
It's lightweight
compared to virtual machines.
Why Docker came into existence? Let's discuss some theory again before going to let's say I am building an application and I am running on a Unix machine, and I am working on a Unix machine. Now, there is a development team which might be testing this application on some different environment. Like they can be testing it on Microsoft. Maybe they have some packages installed on Mac so that they can test the application. The problem is that the developer may be running different version of Java. You have installed, the quality assurance guy has installed different version of Java. Maybe the base OS are different. Maybe the developer has provided some instructions that, okay, follow this guide. Maybe the guide was incomplete. Maybe I misunderstood the statement, and there is always a chance of human error. And the most important thing is everybody is working on different operating system, the developers, the users, the production guys. So the environment is changed and the behavior of the application can change. So now if everybody is downloading the same container, so the container will have same base operating system, maybe Debian, maybe Alpine. It will have the same libraries. It will have the developer knows that the Nginx version should be 1.1.2 for this application. On my machine, maybe I am running the latest Nginx version. Or maybe the developer has used latest Nginx version and I am running the old Nginx version. And if I am testing that app, I will find some bugs in the app. Maybe those bugs are not with the app. Maybe the app is not compatible with your Nginx version, which you have installed for testing. So while using Docker, so Docker has everything inside it, the libraries needed, the OS needed. And whenever this Docker will be pulled by anyone, it will have its own environment. So the user experience will be the same. So that is one more beauty of containers. So I was searching Nginx. So this is the official image of Nginx. And we can see multiple versions of Nginx are available. If we don't mention any version, by default, the latest version is taken into the account. And if we go down, it is telling us how you can run Nginx, how you can make your own container by using Nginx, and maybe it will tell on what operating system this is based on. Okay, anyways, we will see it later. So if we go for MariaDB, MARIA. So we have MariaDB official image available. And we can pull any of the container in our system. What is MariaDB? MariaDB is this, how to run this container, and so on. We will discuss it in detail later, but you can pull a container, you can make your own container, push it to Docker Hub, and anyone can download and use that container. And we have the command docker pull MariaDB and docker pull Nginx. So we were working with Nginx. So we have the command docker pull Nginx. So I will go to my machine and I will run this command, docker pull Nginx. So it is taking the tag latest because I have not provided any tag. So if you can see, it is pulling multiple layers. This is one layer, this is a layer, this is a layer. So you can see it is pulling the layers. And by combining on these layers, by using all these layers, our container will be up. So let's assume we want to run another version of Nginx. So what that can be? I should go to 1.2.5. Let's try that. So with this latest, I will try to have 1.2.5. I think this 31 MB might be the actual Nginx itself, or it can be the base OS. So just observe the time it has taken to download this container. So now I will go with 1.25. Okay, it's not downloading it probably. No, it has downloaded it. So you see the difference? It has downloaded actually. Let me go to the browser again, go some older version. 1.24, 124-Alpine.
I think if you add LTS, then it will also download the latest version, right? If you type.
Okay, I can try. 1.2.40 Alpine Slim. So I can go with 1.2.4 Alpine Slim. Or 1 dash. Let's try 1.2.4. 1.24 dash Alpine. So if I go with Docker images, I have Nginx 1.25 available. The image of this file is available. I have Nginx latest available, and I have Nginx 1.2.4 Alpine available. Though the Nginx with Alpine was way smaller, which is with just 41 MB compared to the latest Nginx. Maybe Nginx has changed in latest releases. Maybe they have gone for Debian. Maybe the footprint of the base container is bigger than it was for the older containers. I don't know if 1.22 is available because it was also on Alpine. Let's see if that is available. So that's how we can have multiple versions of the same app, and we can run all these versions on the same physical machine. They will all run on a same virtual machine in isolation. They will all be listening on the port 80 inside that container, and there will be no conflict at all. We just, after installing this, I will tell you how to run a container. We are now just downloading the images. So just okay. I have all the containers images available, and what I can do is Docker run nginx. First, let me check. Okay, just run nginx. Ng engine. Oh, come on. Nginx. So you can see our nginx is running. And let's say, what should I do? I should open another terminal. I am leaving that terminal as it is, and I am sharing the Docker PS. So one of my container with container ID is running, and it started 31 seconds ago. Status is up, and it is listening on port 80. And it has some name. If you don't give container a name, it will name it automatically. But the problem is, if we do Control C here, so now the container is gone. And if we do Docker PS now, the container is not running. But I can say Docker PS -a. So it will say this container, it ran. Okay, let me clear the screen. This container ran about a minute ago, and now it is stopped. So there is another command by using which we can go into a detached mode or daemon mode. So what I can do is Docker run nginx in detached mode. If I go with detached mode, now it will remain running. If you can see Docker PS, so it is now in running state. What I can do is I can hit this command again and again and again. And if I do Docker PS, now 4 containers are running. So you see, if we have image available, we can run container just like that. So simple. I'm just hitting a command and the container is up and running in a second. And all of them are using the port 80. But let's say if I do netstat -na, first let's check if service httpd status. Okay, httpd is not running. So let's say netstat -na pipe more. On our machine, nothing is running on port 80. And all these containers, they are running on port 80, but they are running on port 80 like inside a container. And we can go inside our container to check if that port 80 is running. So I can go in my container just like that, Docker exit minus interactive terminal and the container ID. And I will say bin bash. Let's see if bash is supported. So if you can see, the command is changed, and now I am inside my container. And let's say inside that container, if I can have netstat. No, this command doesn't work. IPAS. No, this command doesn't work. Cd var www. This folder is not available. etc nginx. This file is available. We have more nginx.conf. We can read a file inside the container, and this is a very small file. It can have 1044 connections and very few configurations and very limited functionality there. So we can go inside our container and we can check if, we can do so much stuff. We will discuss it later. So I am coming out of it. So Docker PS again, and we can pull a container, we can start a container, but there is a command we can do run httpd. So what run will do is it will pull a container and then run a container. It's like two commands we are using. If httpd is not there, I can download it and then I can run it at the same time. And these containers, they are not communicating with the main operating system, and outside world cannot access any of the thing on these containers. So they are running, but they are till now they are useless. So now our Apache is running just like that. And if I hit Control C, Apache is gone. So what I can do is Docker PS, Apache is not running, but if I do PS -a, I can see that Apache ran 23 seconds ago. But now we know that Apache is with us. So whenever we want to run the container independently, so we run the command with -d, so it can go with detached mode. And you can stop all the containers and you can start all the containers by using their container IDs.
Lisan, I have a question.
Yes.
So, which port is HTTPD running when you start it? Since
it's
the
port
containers
80.
are running.
It's port 80 inside that container.
But,
Just like these all port 80s inside these containers.
so it's
So-
running independently.
It's running independently inside till we do the mapping. Let's say I want to run a container, Docker run nginx in detached mode with port 80. Now, this port is the port of operating system, and this port is the port of the container. So we know the container is listening on the port 80, so we cannot change this. Otherwise, the communication will not work. But we can go 8080 here. So we want to map port 8080 of the main operating system to port 80 inside nginx. So let's first do it. And if I hit next stat -na pipe more, now port 8080 has started listening because now I have mapped by port 8080 with the nginx container, which I just ran. And if I do curl http localhost port 8080, it will display as a nginx web server is successfully installed. This is the first page of our nginx. And if I go to the browser, I will type one. Okay, I have not enabled. It will not work. I can tell you why. Because, okay, it's working. I thought the firewall is enabled. So the nginx page is there. And I want to show you that I am, which container was that? Now that's a problem. Docker, sorry, sharing the screen. Docker PS, and let's expand the screen. So you can see all these containers, they are running on the local port, but this one container is mapped on this host on port 8080, and it is forwarding to request to that container inside port 80. And I can show you that what I should do is Docker logs this container dash dash. Okay, I'm going back to my Apache web browser, and if I will hit refresh, you will see that the log is coming to this container. I'm hitting refresh again and again. And what I did is, just like we do the tail -f access log in case of Apache, we do Docker logs -- follow and the container ID, and it will and if we don't do the follow, it will not continuously read the log. It will display the log which is already present there. So we can go inside a container, we can see the container log, we can execute few commands by going inside that container, and we can interact with our container using the host machine or the host OS network by doing the mapping. I hope I am able to, are you getting it? I really hope. And if you're not, we can discuss it again.
But it's making sense.
It's making sense?
Yeah.
Okay, so what I can do is Docker PS, and I have few containers running. And what I can do is Docker stop this, all of my containers at the same time. And if I hit Docker PS, nothing is there, PS minus A. Okay, I go home, I come back again. So by checking these IDs, do you know what was the container which I was using for port 80? I know this is 2F, I can see it. But if this screen is not available, I cannot recognize which was the container I was working on, because the names were festive, I don't know, Sanderson. So we can name our containers. So if I run a container, the same container I was running before, so the better way is I should name my container -- name underscore role. Yeah, sorry, typo. You cannot use a colon in the name. So if I do Docker PS, now our Nginx container is running with the name Nginx old, or you can say, I cannot use now port 8080 because it is used. I can say Nginx latest, and we can use the latest latest image. If I hit enter, now we have two Nginx running, one on port 80, one on port 8080. And if I do Docker PS, so one is Nginx latest and one is Nginx old. So one is listening on port 8080, one is listening on port 8080, and inside both containers we have port 80 available, and we can go on port 80 curl localhost port 80, Nginx is there. If we go port 8080, Nginx is there. So now we have, if I do stop this container and stop this container, I hit Docker PS, nothing is running, PS-A. So now I know this was the container I was working on, because this has at least I have given it a name that it was my latest machine. I was doing some testing on this container, and this is the old installation, and I should start this container. Now, if you pull a container, if you run a container, it will always spin a new container. So if you want to start an existing container, so what you will do is you can do Docker start and the container ID. So it will not create a new container, it will just start this container. So if you do Docker run, it will always create a new container and run it. So if you do the start, it will start the old container. Agreed? Docker stop, sorry, Docker PS first, and Docker stop this container. So all the containers are stopped now. And if I do Docker PS-A, so I want to delete all these containers right now. So what I can do is Docker rm, again, the containers. Okay, let's first go with this Docker PS-A. So all the containers are gone. If I go Docker, the OCK Docker images, I have images available. And if I want to delete any image, I can go with Docker. For that, I used RMI to RM to remove to delete a container. If I do RMI, I can go with the, I can delete an image. Okay, you cannot delete it because images referred in multiple repositories. That's what I was saying. So that, let's say I want to hit delete this one. No, you cannot delete this one. Docker ps -a Docker img eds. I think I can delete this one. Docker RMI. Yes, I can delete this. Actually, this is an image ID and this is an image ID, and they both are using the same image ID actually. So that's why I was not able to delete it. This has totally different image ID, so I can delete it safely. So I can do again Docker images, and I have deleted this 1.2.2 version. And we still have HTTPD available. Any confusion till now? So we can install MariaDB container just like that. Yum pull Maria MARIADB. Oh, come on, yum pull Docker pull. And while working with Dockers and containers, we will deploy our website on that container, on this container, and we will see how we are gonna do it. We will set up the database example here. We will use the password ABC123 here, and we will continue with the old scenarios which we have taken from the start of this session or the class or this course, that we were running our PHP website and a database, and we were running the PHP code and the database. We are connecting to that database through that PHP code. So we are simulating an application scenario. We did that through just like on CentOS, native OS, we did it with maybe Ansible, and I think we did it with Puppet also. So we are taking the same scenario and we are taking it to the Docker. So we can see, we can run our scenario using all these technologies, and we can see the benefits of every technology. So just wait for it to download. Okay. Huge size. In the meanwhile, till it is downloading, you can ask me if anything you want to ask.
So the difference here is, so when we were installing these packages individually in our machines, everything here is just compiled in one, and it's easier to deploy.
In Docker?
Yeah.
Yes, of course. You don't need to configure the Nginx server. You just pull a container and your Nginx is running. You pull your MariaDB container, it starts running. You don't need to configure PHP. You will download the container which has PHP already available.
Yeah, no, it makes so much easy.
So much easy. And of course, you have an application. For that application, you need, let's say, Apache, PHP, and the application code. So what you will do is, you will install a CentOS or whatever machine you want. You will install Apache, you will install PHP, you will download the code from Git or GitLab, GitHub, and you can start your server, and then you can browse your application. I mean, you have to do so much stuff. What you will do now in container is, you will just download the container. The application is packed inside. Everything is packed inside. You pull a container, you run a container, and boom, your application is running. So you see the deployment time has reduced so much. The environment dependency is gone. And the container, you can run any number of containers and you can put a load balancer in front of it and you can start spinning container like in a second. You have image available, you are just running the containers and adding in your load balancer. You can handle the load very easily. In case of VM, you have to clone the VM first, then it can take about 15-20 minutes, then you can run it. And for another machine, you need another 15 to 20 minutes. So pulling in container, once the image is there, you can just hit docker run image name, docker run image name, and your containers are spinning like that, and you are just doing the mapping of the port. So it is very the deployment time is reduced, and you can very easily handle the load. This is why nowadays everything is shifting towards containers. All the apps are going towards microservices. These are the container, the Docker container. It's the basic building block of that microservice. Let's say I want to deploy MariaDB is there. So what I can do is I can go on the website again. And I can go with Docker Hub. MAR. I'm using the official images. There are tons of images available. So I can just pull MariaDB. I just did that. And what I can do is starting MariaDB instance with latest version is simple. I can give the name. I can create an example user from which I can log into the container. And I can set the password. From that password, I can log into the database. And I can set the root password here. And I'm saying that I'm using the latest version. So I can copy this command. Okay, from here. Control C. And I can go back to my container. Sorry, the prompt. And let's say I want to modify some parameters. I can name my container as my MariaDB. And I can say the sample user is test. And the password is root 123. And the root password is also root 123. Do I need to explain this command or should I hit enter?
Hit enter.
Hit enter. Okay, done.
Yeah.
So our container is there. So if I do docker ps docker ps, I can say docker exec interactive terminal, the container name, and bin bash. I went into the container. If I hit MySQL minus u root minus p MySQL. I'm inside my container. Why? Exit. MySQL is not coming into the path. Let me download another container or another image. I can go to the. I don't know why it's not working. I can go with MariaDB 5.10.5.21. And I can set MariaDB 2. Docker run detach minus name environment variable test root 123. It should work. Okay. Docker PS, and this is my container, MariaDB2. So Docker exec interactive terminal, then bash MySQL -u root -p. Yeah, now that's working. I don't know what was wrong with that container. And we set the password root 123. So our database, if you remember earlier, we had yum install MariaDB server. We did service MariaDB start. Then we ran MySQL secure installation. We set the username password, and we can log into that. We ran our database. So it was a long process. Now I have just downloaded a database container. I gave the environment variables, and it just utilized those and set everything for us. Now I can do is create database example and hit enter. And if I show database, our database example is there. So if you have any question till here.
So are we going to go into configuration, just like we did when we were installing these applications manually?
Yes, we will be doing the same scenario. We will have our container with our own application, with our own application code. We can create a database, we can run a database, and we will be testing the same scenario, which we are doing it since the start of this course.
Got it.
We will create our own container. We will push it to the repository, and then we can pull it from that repository, and then we can test our website. Okay.